Hello and welcome. In this last video in the series, we'll go over how to configure the last two sub-workflows. The update sub-workflow will help you maintain your vector database long-term by helping provide a method to check the pages you've already scraped for updates rather than needing to do a full crawl every time. We'll also go over the Sitemap Sub-Workflow, which allows you to extract URLs from the site's sitemap as an alternative for crawling. So let's get started. Here in the manager, we'll set the sub-workflow to update and then open it up. We don't have anything to really configure here in the set inputs node like the other workflows. Instead, we'll just make sure our credentials have loaded into Sheets. Then we'll grab our data. I have a previous crawl of ready.gov sitting in my upsert output. So I'll use the input management tool to copy that data to the input sheet. Then go back to the manager. I'll disconnect the loop for our first run and execute the workflow as a quick test. Then in the update sheet, we can see that it checked the first web page and gave us some data to compare with. Section A is the most recent check of the website, and section B is my last crawl. The last modified value gives us a date when the web page or PDF document was last updated. The E tag or entity tag is a unique identifier for this version of the web page. And finally, we're hashing the entire web page itself. So taking this data at face value, we can assume that the page is updated and we should send it to our scrape sub workflow to get a copy of the new changes. However, that's not actually true. The ready.gov site hasn't been updated in some time due to lack of federal funding. At the bottom of the home page, it even says the page hasn't updated since mid-February. So what's going on here? The system that manages ready.gov may be republishing the site every so often, thus affecting the last modified value, even if the content hasn't really changed, which can also affect the E tag header. However, that doesn't really explain what's happening with the hash values. If the content is essentially the same, then the hash value should be the same as well. So let's go into the Google Drive and look at our formatted data for the home page. I'll copy it and then throw it into a character counter, which reveals the last time I scraped this home page, there was 213 words. Okay, so let's compare to today. We'll make use of the data preview tool we covered during the crawl video and use it to get a quick word count of the web page. Sure enough, 213 words even today. Let's go to the HTML of the page to take a closer look. If I take the HTML from this output and throw it into a quick text compare website, then grab my original unformatted HTML from Google Drive, we can see that yes, there are in fact some small changes to the structure of the website, but not exactly the user-facing content. This simply means we need to change our approach for the next scrape of ready.gov. Inside the scrape and crawl on one workflows, we can activate this optional node, which will hash the markdown values of the page, which is essentially the extracted text, rather than the entire web page. So now knowing how this site operates, we can change some things in the update sub workflow to ignore some of these headers. We can go to the compare node here, then set all of these headers, except for the hash values, to ignore. Being mindful of the formatting for commas. Then we can enable the optional markdown hash value comparison. And now we're in a much better position to continuously keep up to date with the website as it changes. I'll head back to the manager to reconnect the loop and finish the job. So now, of course, the web pages are still identified as different because we're ultimately going to start hashing the markdown values. However, the PDFs remain unchanged. PDF documents do not have an E tag value, just for your reference, and we can see the hash value for the PDF document itself is the same, so we can trust that this is in fact the same document. I'll let the job finish and skip ahead. Okay, so now we have a full list of all of the URLs we want to scrape. Though before we do that, I want to make a copy of my existing namespace. I have a tool to help with that, so check the Tools folder for the Copy Namespace workflow. We'll need to paste our Pinecone host name into the Set Input node, and we'll do the same for the target namespace. The target namespace would allow you to actually move data to a completely different index or even onto a different account if you'd like, though in this example, it's the same index. I'll add the existing namespace name and change the C to a D for differences, which helps me know which namespace is what. Now all we have to do is just double check the Pinecone credentials in these nodes and set the copy namespace workflow at the end and publish. We can kick off the job and monitor its progress in the namespace itself. Then in just a few minutes, we have a complete copy of our namespace to work with. So if your existing namespace is already published to your user base, nobody will be affected by the changes we're about to make. So before we bring new data into the system, we need to clean up the old data detected in the Update Differences sheet. Head on over to the Cleanup Vectors tool. Set the Inputs node to the Pinecone hostname and namespace. Then make sure the Google Sheet credentials are working. This process uses the file name metadata to know what items in the vector store are actually from what document. So the Google Sheet will pass that information to this cleanup HTTP request to remove them. Then we take that same sheet using the Input Manager tool as input for our scraper. Now all that's needed is to run the scrape on these updated URLs, upsort them into the new namespace, and update the query KB agent to point to the new namespace. I recommend writing a few baseline questions so you can test after each full crawl or update workflow to ensure the data is correct between the namespace versions. Next, let's look at the Sitemap Sub-Workflow. As an alternative for crawling, you can extract URLs from a Sitemaps XML document. Web admins will often keep this document updated with the most important web pages, so search engines know where to look. Which means the sitemap list can be significantly shorter than what you might find in a crawl. Still, it's a very helpful way of getting URLs. The Set Inputs node contains the same type of filters available in the Crawl Sub-Workflows and Data Preview tool. So for ready.gov, I could remove some of those extra language sections if I wanted. As for our first entry, you can usually find the sitemap just by going to the home page of the website and then adding /sitemap.xml. I'll use the first input entry node to throw that XML in there. And then kick off the manager. As you can see, it brought in a lot of URLs, and if I were to keep the loop going, it would check each one to make sure it's active. Therefore, the final sitemap output contains a list of only validated URLs extracted from the sitemap.xml. Alright, so this works pretty well on smaller sites, but for sitemaps like the National Park Service and NASA, Google Sheets starts to choke on the sheer amount of data. That's when we need to look to a service like Supabase to help. As I mentioned in the agents video, Supabase is another free service that we can use to host our data tables and is much faster than Google Sheets using a version of PostgreSQL. Let's head to supabase.com and create an account. I'll select Start a Project and Sign Up, then create some login information and verify my email address. Create a new organization, leave everything as default. I'll generate a secure database password, then create a new project. Next, I'll go into the table editor and create a new table. In similar fashion to Google Sheets, I'll be creating tables for input, error, processed, and sitemap output. So I'll start with input. I'll leave the ID and created at as default and add some new columns for job, execution, and source as text data. That just keeps things easy for this example. The error table is very similar to input, but we'll have the error column as well. processed and sitemap are essentially the same as input. Once our tables have been created, we'll go to Project Overview and copy the project URL. We'll need that to set up the credentials in init-end. Then also go to Project Settings, API Keys, and copy the secret to a safe place. Now I'll open up one of these Supabase nodes and create the credentials. Paste the project URL into the host section and the secret into the service role secret, and save. Great, so in the extra section of the workflows, you'll find the Supabase version of the manager and sitemap. Like the previous workflows, all we're doing here is making sure the credentials load all right, and I'll set the Supabase Sitemap Sub-Workflow. For this demonstration, I'll be using NASA's sitemap, which has over 70 XMLs filled with thousands of URLs. I'll add the top-level sitemap XML as input into the manager. Then I'll remove a loop so the workflow just runs once. Now let's see what we've collected in the Supabase input table. We now have a list of all the XMLs from the sitemap. I'll reconnect the loop and run this a bit. It'll take about 10 minutes to run through the XMLs and then get all of the URLs extracted into the input sheet. Alright, so as you can see, we have a lot of data in our input table now. And just like the Rubel Sheets approach, the process table shows the XMLs of process along with some of the URLs. Even with all these improvements, it will take a long time to validate all of the URLs from a sitemap as large as this. I have a few tools in the extras folder to help you clear this data or use it as input for the scraper. Alternatively, you can download the entire table as CSV and just take the entries you need, which is exactly what I did to create a little treat for those of you who have made it to the very end of the series. I've selected a few links from NASA regarding the Artemis missions and the moon in general, so we can ask some very important questions. First of all, for those not aware, what are the Artemis missions and what is their overall objective? Essentially, NASA is returning to the moon, albeit a different part of it, where they're going to run some experiments and see if it's even possible to live there long term, which would help prepare for future Mars missions. So the Artemis missions are already underway, but when is the next major one? The Artemis 2 mission will happen very soon, sending a crew of astronauts in orbit around the moon and back, which of course is very similar to the Apollo missions, so how do those compare? Honestly, this is really cool stuff, and great that we'll be able to witness such a historic event in our generation. Though in the age of AI, I'm sure the authenticity of these missions will be criticized more than ever. Which leads me to my final question. Did we really land on the moon, or was the Apollo moon landing faked? Well, there's plenty of samples collected, and they did quite a few experiments on the surface. Plus, over 400,000 people would have to be in on it. I don't know. Maybe we just need more data to know for sure. And with that, we've touched on all the components of the knowledge base system and how to use them. I hope they prove useful or provide inspiration for your next project. Thank you so much for watching.